Hi students, welcome back. Coming to the next concept in the database management system is the B trees. So far you had seen the B trees concept in the data structures. So just like in the data structures in the database management system also, we are using the concept B trees to retrieve the records from the disk to the database. Okay, so we have to get the data from the disk to the database, and from the database to the we have to retrieve the data from the database by using the concept of B trees. So now have a look on this. Before going to explain about the B trees, just recall the indexing. The indexing sort of two types. I already explained: single level indexing, and multi-level indexing. Indexing is of two types: single level indexing and multi-level indexing. In the previous video I explained about the single level indexing, that are primary indexing, cluster indexing, and secondary indexing. So these are all I already explained in the previous videos with an example. So if you didn't watch these videos, just go and watch that videos which explain these three comes under the category of single level indexing. Now coming to the multi-level indexing. The multi-level indexing is of two types. One is the B trees and another is the B plus trees. Okay, so in this video I want to explain about the B trees, and next I'll explain about the B plus trees. So before going to learn about this B trees and B plus trees, which are the multi-level indexing, so I want to give a clarity regarding the single level indexing and multi-level indexing. What is the difference between the single level indexing and multi-level indexing? Okay, so you guys already know that because I already explained the previous videos. Just recall that thing. Single level indexing, what the concept of single level indexing means. So here you have to take the index file, so which we call it as a root file. Okay, index file is there. So the index file consisting of the key as well as the block pointer. Means the block pointer means from where we have to get the data, so that address will be there in the block pointer. Okay, and this is the index file, and here is a data file which is present on the secondary memory. Okay, secondary memory or the disk, okay, whatever it may be. So data file will be present there. So this data file is divided into block pointers: block pointer 1, block pointer 2, block pointer 3, like that. Means in each block pointer you are having some storage allocation to store that data. Okay, so there is a direct communication between the index file and the data file. This type you call it as a single level indexing. This is also indexing file and this is also the index file. Okay, data file is also index file and this is also the index file. So there is only one communication line is there. So only one level is there directly from index file which is communicating with the data file. This concept you call it as a single level indexing. Okay, so here the keys will be there for key 1 data, key 2, K2 data, K3, like that. Keys will be there, and the block pointer 1, block pointer 2, block pointer 3, like that. So these are the index files which holds the key value as well as the block pointer, so which is accessed by the database. This is a single level. Now let's have a look on the multi-level indexing. So this single level indexing we already seen with an examples of primary, cluster and the secondary indexings with an examples. Now have a look on the multi-level indexing. So I said the multi-level indexing or the B trees and B plus trees. Before going to know about the B and B plus trees, let's see what is this multi-level indexing. So we know that single level indexing will communicate directly with the data files and the index file. So index file consisting of the key as well as the data pointer or the block pointer, and it's consisting of the block pointer 1, block pointer 2 divided into block pointer 3, like that. Okay, so if we directly communicate the index file to the data file, that it is a single level indexing, but it takes a lot of time to communicate with the index file directly to the data file. Every time it is going to the secondary memory and getting the data, means it takes a lot of time. Okay, cost will be more, time taking will be more, everything is more. So that's why we are using the multi-level indexing. Multi-level indexing, in between that there are internal nodes, and we have the leaf nodes. So that's why we call the node concept will be there in the trees only. So this is the internal node. Okay, this is a leaf node, and this we know that this is a root node. Okay, so the multi-level indexing, if you want to communicate with the data files, the index file will be communicate with the internal node with the leaf node. So where we in the leaf nodes we actually have the data values. So the data pointers will be present in this leaf node. So this data will be stored on the data files. So whatever the data that is present on the secondary memory or the disk, that will be stored in the leaf node. So that will be sent to the internal nodes, and that will be exactly stored in one record. Okay, suppose the index is consisting of employee ID, that is which is a key value, and the record pointer. This is my index file. Okay, index file consisting of my employee ID. With the help of that employee ID, I am accessing the record pointer of that particular employee ID. So employee ID, so many employees will be there, 1, 2, 3, so many employee IDs. So with the help of this key value and the record pointer, I can go to that particular data point, that is the record pointer or the block pointer. I'll search that particular person's record, and I can retrieve the data and I can insert the data there. So this is just an index file, and whatever the data file consisting of the table, a table consisting of employee ID with the name, address, age, like that. So many fields will be present for that particular employee ID. So this is completely the record pointer of that particular employee ID. Record will be present on the table. So this is how the multi-level indexing will be there. This is the root node. So the database will access the index file, and this is an internal node which is another index file, and this is a leaf node which is another index file, each consisting of the base, that is the block pointers, divided into block pointers. Okay, each one is divided into block pointer. Okay, so it consisting of the node pointers or the block pointers, and it have a record pointer also. So this is a multi-level indexing. So many levels are there: root node, internal node, leaf node, data file. If you want to access the data on data file, so we have to divide the data into internal nodes, leaf nodes, and the data files. So before going to know the concept of the B trees, I want to give some properties on this B trees. The B trees at every level, we have a key and data pointer, or we also call it as a block pointer. So every level a key will be there and the data pointer or a block pointer will be there. And next, a data pointer actually pointing to either block or record. So whatever this data pointer will be there, so that can be pointing to either record or block. Okay, so let's have a look on the properties of this B trees. Properties. So first, root. Okay, so every node has at most m children here will be there. That is the root consisting of a children in between 2 and p. So 2 is the minimum value and the p is the maximum value. Means if root is there, a root consisting of 2 children. Minimum 2 children will be there. The maximum any number can be there. So this is a one property. So that means the root node consisting of what I said, a key will be there and the pointer will be there. Okay, key will be there and the pointer will be there. So here one children pointer will be there, that is the record pointer, and here another children pointer will be there. So each node, a root node consisting of minimum of 2 children. Minimum of 2 children and maximum any number can be there, but each root node consisting of 2 children. Okay, so this is a root node. Okay, suppose n is equal to 1, which means the root. N plus 1 is equal to children. How many children? 2 children. Suppose n is a root, okay, which is a 1, and n plus 1 consisting of children. So root 1 means n means children is n plus 1. Remember this formula. N and n plus 1 will be the children's. So we already know that the B trees or the binary trees, okay, the binary trees, the left hand side should be less than the root node and the right hand side should be greater than or equal to the root node. That you have to be remember that. So this is the first point. Let's have a look on the second point. The second point is let's talk about the internal nodes. Internal nodes. Internal nodes. Okay. So the internal nodes means here internal nodes consisting of children. The children between seal of P by 2 and P. So P is nothing but the maximum. Okay, the maximum children. So children of internal node bits, it's a seal of P by 2 and P. And what about the keys? The number of keys that are present on the internal nodes is between seal of P by 2 minus 1 and P minus 1. So this is the minimum and the maximum. Minimum and the maximum. Minimum and the maximum. So next properties come to the leaf nodes. The leaf nodes condition is, one thing is all are at same level. Same level. So the keys in between, in the leaf nodes, the keys are in between seal of P by 2 minus 1 and P minus 1. So this is the condition. So children is always P by 2 and P, and keys is P by 2 minus 1 and P minus 1, because these are the internal nodes. Internal minimum is P by 2, minus 1 is the keys, and children is P by 2 only. Okay, it's not minus 1. So these are the properties of the B trees. Okay, so in the next video, I'll take an example of the B tree. Thank you.